Welcome back to my channel. As I said before, we're going to go through the laws of exponent or exponent laws. So there's about 5 laws that you have to understand and have them at your fingertips when you're solving the sums that involve exponents. So the first law, as you see here, it says a to the power m multiplied by a to the power n equals to a to the power m plus n. So what does this mean? So it means that, remember we said that this is a base, right? And this is the base. So if you have base a and base a, and we are multiplying, which is very important, we should be multiplying. So if you have base a and base a, and we are multiplying, what do we do to the exponents? We add to the exponents. We add the two exponents. So this law basically says if the bases are the same and we are multiplying, we add the exponents. So there should be two conditions. There are two conditions. The first condition is that the bases should be the same, and the second condition is that we should be multiplying. If those two conditions are satisfied, then we can add the exponents. Okay, so let's go to the second law, or law number 2. Law number 2 says if the bases are the same, in this case we have a and a, if the bases are the same and we are dividing, what do we do to the exponents? We subtract the exponents. I'll repeat. If the bases are the same and we are dividing, what do? We subtract the exponent. So again, here there are two conditions. The first condition is that the bases should be the same, and the second condition is that we should be dividing. And if those two conditions are satisfied, then we need to subtract the exponents. So what is even more important for this law is that when you're subtracting the exponent, you subtract the exponent of your denominator from the exponent of your numerator. In this case, the denominator is a to the power n, and the numerator is a to the power m, which means we're going to subtract n from m. That's why we have m minus n. Okay. So the third law says if you have brackets and you've raised whatever is inside the bracket to a power, in this case is q, or to an exponent q, every exponent inside the bracket is multiplied by this exponent which is outside the bracket. So in this case we have a to the power m multiplied by c exponent p divided by b exponent n. All of this is raised to the power q, or its exponent is q. So what does the law say? It says you multiply everything by the q, as we're seeing here. So we say a to the power m multiplied by q, c to the power p multiplied by q, b to the power n multiplied by q. That's what the law says, provided that b is never equals to 0. Just remember, if b is equals to 0, that means all of that is 0, and if we divide by 0, the answer is undefined, so there is no answer. The other important one is this one. This says that a to the power 0, or any base to the power 0, it could be a b, a c, a 2, a 1, a 10, a 15, if it's raised to the power 0, the answer is 1. So any number or any variable raised to the power 0 is equal to 1, provided that a is not a 0, which is the base. The other law, which is the last one, says that the base exponent m, or a exponent m, this is an a exponent m is equals to, or can be written as 1 divided by a to the power negative m, right? So a to the power m can be converted into 1 divided by a negative m. Notice that in this case your a is a to the power m is now changed to be a denominator, but not only that, the exponent changed from being a positive to a negative, which means if we had, just do this, if we had a negative m, this was going to be a to the power a m. So here what we did is a to the power m. So if we want to make a to the power m to be the denominator, we now need to change that negative to a positive. When it was a positive there, we changed it to a negative. And when it's a negative, we must change it to be a positive. So these are the 5 laws that we're going to use going forward as we solve sum that involve exponents. In our next videos, we'll be doing exactly that. We'll be using these laws to solve sums that involve exponents. Thank you for listening. Please subscribe and like for more videos. Thank you so much. Bye-bye. Welcome back to my channel. So today we're going to simplify using exponent laws. So we're going to simplify using exponent laws. So our first sum is 2 to the power 3 multiplied by 2 to the power 2. So the first thing that you should look for is, are the bases the same? And here our bases are the same. We have a 2 and a 2. What does exponent laws say? One of the laws says that if the bases are the same, we add the exponents, right? So this is going to be equals to, since the bases are the same, which is 2, we then add the exponent, which is 3 plus 2. Our final answer is going to be 2 to the power 5. Okay, so that's the final answer. Then if you go to the second one, again you have 2 to the power 6 multiplied by 2 to the power 4 divided by 2 to the power 7. So I'm just going to rewrite this as follows. This is 2 to the power 6 multiplied by 2 to the power 4 divided by 2 to the power 7. Okay, so what do we notice here? We notice that the numerator, it has 2 to the power 6 multiplied by 2 to the power 4. So since the bases are the same, we have a 2 and a 2. What does the law say? It says we need to add the exponents. So this is going to be 2 to the power 10. We then divide by 2 to the power 7. Right? Now we have a division. So now we need to divide. And what does the law say? It says if the bases are the same, we subtract the exponent. So the answer here is going to be 2, 10 minus 7, which is equal to 2 to the power 3. And 2 to the power 3 is 8. Okay, so that's the final answer. So let's just recap. So we were given 2 to the power 6 multiplied by 2 to the power 4 divided by 2 to the power 7. We rewrote that into 2 to the power 6 multiplied by 2 to the power 4 divided by 2 to the power 7. We then notice that the bases are the same. We have a 2 and a 2. In our numerator, we have a 2 and a 2, and the law says if the bases are the same and we are multiplying, we add the exponents. So this became 2 to the power 10, and this 10 is 6 plus 4 is 10. We then divided that by 2 to the power 7. Now that we are dividing, one of the laws says if the bases are the same, we subtract the exponents, and the exponents in this case it's 10 and 7. So what we're going to do, the base is 2, then 10 minus 7. The exponent is 3 now, so it's 2 to the power 3, and 2 to the power 3 is an 8. And thank you for listening. We'll do some more sums, simplifying using exponents. Welcome back to my channel. So we are simplifying by using exponent laws. So let's go through the two sums that are on the board. So the first sum, we have 2 to the power 2 multiplied by 2 to the power 3 multiplied by 5 to the power 2 divided by 75. So what I'm going to do, I'm going to look at that. So here we have two bases that are exactly the same. So if they are the same, what do? We add the exponents. So this is going to be 2 to the power 5 multiplied by 2 to the power 2. So I'm going to raise 70, or I'm going to write this in an exponential form, which is 5 to the power 3. Okay. So what do we have now? So now we have 2 to the power 5, okay, multiplied by 5 to the power 2. Then we have a divide here, divide by 5 to the power 3. So what does the law say? The law says if the bases are the same and we are dividing, we subtract the exponents, right? So it means this is going to be 5. 2 minus 3 is going to be minus 1, okay, which is going to be 2 to the 5 divided by 5. So this is our final answer. So let's recap. So we looked at the numerator. We noticed that there are two bases that are exactly the same, 2 and 2. We now know then if the bases are the same and we are multiplying, we must add the exponents, which is 2 plus 3, which is equal to 5. Then we left this 5 squared as it is. We haven't done anything to it yet. But the denominator, what we did, we raised the denominator to power 3, because we then realized that now you will have a 5 base and a 5 base as your denominator. So the law says if the bases are the same and we are dividing, we need to subtract the exponents. So 2 to the power 5, we then say multiply by 5, 2 minus 3, which gives us a negative 1, exponent negative 1. So if we bring this term to be a denominator, we need to change that to be a positive. So we have now 2 to the 5 divided by 5 to the power 1, which we normally don't write. So this will be our final answer. So now let's look at the second one. So the second one, we have 3x to the power 4 multiplied by y divided by 9x to the power 5 multiplied by 2. So if we look at the numbers, we have a 3 and a 9, which we can simplify this to be 1 over 9. 3 goes once, 3 goes 3 times. So we're going to have x4y divided by 3x5y squared. Now we are dividing, so we can look at the bases. So if you look at the bases, we have x to the 4 as your numerator and x to the power 5 is your denominator. We have y divided by y squared. So we can then subtract then the exponents. Right? So we have x to the power 4 minus 5, which will be minus 1. So y minus 2, y to the power 1, so it's going to be 1 minus 2, which is y minus 1 divided by 3. So to simplify, we can bring this at the bottom and then the exponents become positive. So we're going to have 1 divided by 3xy. Okay. So this will be our final answer. Thank you for listening. See you in the next video. Welcome back to my channel, where we are simplifying by using exponent laws. So if you look at the first sum, so the first sum says 2 to the power 2 plus a multiplied by 2 exponent 2 minus a. Again, first thing that you look for, are the bases the same? And in this case, yes, our bases are the same. We have a 2 and a 2. And what does the law say? The law says if the bases are the same, we add the exponent. So we're going to say 2 plus a, we're going to add all of that, which is 2 minus a. Okay, so we now have 2 exponent 2 plus a plus 2 minus a. Now since we have the like terms, so this is going to cancel that, then we'll be left with 2 to the power 4, which is going to be 16. So 2 to the power 4 is 16. Okay, so let's recap on this one. So we look at the two terms that we have, and the bases are the same. We have a 2 and a 2, and the law says if the bases are the same, we add the exponent. So the base is 2, and we need to add 2 plus a to 2 minus a, which is 2 plus a plus 2 minus a, and a, positive a, will cancel the negative a, and we are left with 2 to the power 4, and 2 to the power 4 is 16. Okay, now let's look at the second one. So the second one, we have brackets. They've given us brackets, and everything in the bracket is raised to power 4. So we remember one of the laws that says if whatever is inside the bracket is raised to a power, we then multiply the power of that bracket by the power of each and every element inside the bracket. So in this case, we're going to say this is 2 to the power 4, so 2 to the power 4, multiplied by 3 times 4, which is a 12. Okay, so 3 times 4 is 12, multiplied by x, 1 times 4 is a 4, divided by y, 2 times 4 is a 8. Okay, now is there anything else that we can do? So we have now 2 to the 4, 8 to the 12, x to the 4, and y to the 8. There's nothing else we can do. The only thing that we can do now is to change that. 2 to the power 4, we said it's 16, so it's 8 to the 12, and x to the 4 divided by y power 8. And this will be our final answer. See you in the next video. Bye bye.